Hello, my name is Sarah Barnes, and I'm a 7th grade math teacher at Allen Middle School in West Shore School District. This is my second year at Allen and my second year teaching in general. I actually went to Millersville for my bachelor's in mid-level math education and graduated from there in 2017. And then I started back at Millersville this past summer, pursuing my master's in assessment curriculum and teaching with a concentration in integrative STEM education. And the reason I chose this particular major is because I've always had an interest in STEM. I've always enjoyed building things. I loved my technology and manufacturing classes in high school, and I was a little surprised that I was the only girl. So I figured going into this major and learning more about STEM education, I could get more of my students interested and invested in STEM and maybe pursuing a career in STEM. My life outside of school, I drink a lot of coffee, eat a lot of chocolate. My favorite candy bar you can see here is the Three Musketeers bar. But I do really enjoy crafting and painting. I did just get married almost 2 months ago, and I made everything for my wedding. So here you can see I made our two little coffee signs. I also made this sign with our name. I made a whole bunch of other things, but they do not fit on this slide. Now getting into the questions for this class, the first one, how do students learn science? I pulled out my favorite quote that I thought answered this question from our readings. According to the new guidelines for science education, students learn science by, or I should say, teachers help students learn science by helping students develop, first, a familiarity with disciplines, concepts, theories, and models, 2, an understanding of how knowledge is generated and justified, and 3, an ability to use those understandings to engage in new inquiry. As opposed with traditional science teaching, the way students should be taught science now also includes a heavy reliance on inquiry and metacognition, even if that metacognition is simply just a form of self-assessment, and really making sure that students understand science at a conceptual level and not just that they are memorizing facts. I really feel, and I read in the readings, that if students do not understand science at a conceptual level, I don't think that they really understand science at all. When discussing the barriers to science learning, I think there are two major ones. The first is that students come into our classes with strong prior misconceptions or preconceptions about certain topics. Even though we read in the readings that we know that students can base new and correct scientific learning off of a previously adopted preconception, if the new learning is not taught well enough, students can revert back to that old misconception, and that completely undoes that learning. I also think that there's just a lack of metacognitive learning or self-monitoring in general. Page 10 of the Donovan and Bransford text mentioned that even the best instructional efforts can be successful only if the student can make use of the opportunity to learn. So if our students don't want to learn or don't have the ability to take control of their own learning or aren't taught how to take control of their own learning, that's really going to set them back in how well they're able to learn. This question was kind of tough for me to answer because I am not a science teacher, I'm a math teacher, but I was able to pull out a couple of things. So first, I address preconceptions and misconceptions in all my lessons. For example, even though I teach 7th grade math, students still have that idea that, oh, if I multiply any number by 10, that adds 0, but they don't understand that what that really means is the place value is moving. So if I give them a number like 1.5 and I have it multiplied by 10, they don't move that decimal, they just put a 0 on the end. This relates to the second part of concepts taught prior to facts. I am teaching right now about equations, and I'm actually teaching my students by using hands-on equation pieces. And the reason I'm doing that is because I want my students to understand the commutative property and how to combine like terms and other things at a conceptual level, rather than teaching them, okay, the commutative property means this, memorize this definition for your test. I also do use a lot of self-assessment. I have something that I use every day called a daily survey, where my students will answer a Google form and they'll rate their understanding of the day's lesson, and they'll tell me why they chose that rating. So that's great for two reasons, because first, it allows me to see, okay, are they learning what I am intending to teach them? Or do I need to go back and reteach? But it's also great for them to monitor their own learning. I also have them track their own learning goals. We use interactive notebooks, and at the beginning of each chapter, they color in a little bar, and they continue coloring it in as they progress towards the learning goal that is next to that bar. As for my STEM perspective, I think I'd place myself at the figure 8.6 that demonstrates coordination across disciplines. One major example I can think of right now is that I'm teaching my students how to calculate area, surface area, and volume of composite figures a little bit each day. And right now the science teacher is also working on volume with some of his regular content. Even though I would place my current level up here with coordination across disciplines, I do know that figure 8.8 is really what it's all about, and that true STEM education is an integration of all 4 subject areas. I would love to be here where you see the transdisciplinary version of STEM, but right now my district does not offer a course like this. And here are my sources. Thanks for watching.